I'm Matthew Peterworth. It's great to be here today. I'm with PAE Engineers out of Portland, Oregon. Before we get started, I'd like to thank Ray. He's not in the room right now, but I'm sure he'll be watching the video here in the next few weeks. I want to thank Ray for not only putting on this great conference now for the second year, but also for selecting me to present to you today. I am terrified of public speaking, but I am more concerned about what we do in our industry and how important it is that we design the best security projects we can for our clients. So figured I emailed him a list of topics I can talk about, and this is the one he selected this year. And as you know, this is structured cabling best practices for video surveillance. So I'd like to thank you for selecting my presentation to attend. I know there's a lot of other good presentations in this time slot. So again, thanks to the conference for recording all of them, and you'll be able to reference the other, watch the other presentations later. Oh, and thanks to Altronics for sponsoring this design track, and we'll get a little bit into that towards the end of the project. So again, thanks to Altronics. So a little bit about me. I work for PAE. We are a 300-person MEP firm with offices in Portland, Seattle, and San Francisco. I work in their specialty technology team, so I do a wide variety of designs from telecom, audio, video, electronic security, emergency responder, DAS coverage. All of that falls under my purview. Before I worked at PAE, I worked for Henderson Engineers, which is another mechanical, electrical, plumbing engineering firm. They actually hired me out of college in 2006, straight into their technology department. And I started there as a telecom designer. And so after a couple of years, I was able to sit for the RCDD exam. That's the design certification from Bixby, which is very difficult to pass. Fun fact, on my third attempt, I actually flew down to Houston on my honeymoon to take the RCDD exam. And I'm glad I passed, because I think after a month together, my wife probably would have divorced me if she had to follow me to take another test somewhere. So I was working with Henderson. Right in the economic downturn, I decided to hedge my bets, and I moved to Austin, Texas to work for the University of Texas at Austin. I worked in their central IT department from 2010 into 2012. And that's where, as you know, if you start a new job, you maybe not have full load for design projects. So the first month or two, I was tasked with updating their Division 27 specifications. And that's where I put my owner hat on, right? And as I was writing these specs from scratch, I got it in my mind. Every line is important, and not to have any extra requirements in it that don't matter, right? And they have to add value to the owner. So what's the point of having these really stringent requirements if they cost more to install, but then there's no added benefit through the life of the building? So those were the two main things that I really took hold of, and I continued to do my specifications that way now that I'm back on the consulting side. While I was down in Texas, I passed my professional engineering exam. It was open book, so arguably a little bit easier than the RCDD exam through Bixby. I've since added licensure in Oregon and Washington, since I am now based out in Portland. So what are we going to talk about today? Here are the three main topics, right? So the first is what kind of category cable is best. Pretty short section. Next we'll get into the NEC Code Requirements. And this is going to be really high level, and I'm cherry picking the ones that I care about, the code requirements that I make sure I personally design around. And the NEC, National Electric Code, it's a 700-page document. It's very exhaustive. There's going to be a lot more in there that we as the designers need to follow and understand. But I won't be, today's session is not going to be comprehensive. So this is just more of a tip of the iceberg. Here's what I think we need to be designing around. And a little preface, another preface on that section. That's just my interpretation of the code, right? So if you have a project and you're disagreeing with the code official, don't go saying, hey, Matthew Peterworth, he's a PE in Oregon, he thinks the NEC means this. So this is not that to that level of authority, just sharing my best practices and my interpretation of what's important from the NEC. And then finally we'll get into the longest section, which is the specification best practices, which is what I've seen in the industry, and then of course what I've earmarked as my own personal best practices. So as I'm going through that section, I'll try to clarify, here's industry, and then here's what Matthew Peterworth says and how he designs his project. So moving into what kind of CAT is best. So some of you, if you've done a little bit of telecom, all of this you know already, but just running through the basics to make sure we have everything covered. So Cat 5e, Cat 6, and augmented Cat 6 or Cat 6a. Those are your three main cable types. TIA 568. There's a whole host of standards under that number with lots of dots and sub-dots and sub-standards. All under that purview, and that's where they define these top three requirements. So if you sat in on the pond session earlier today, you know this 295 feet is a hard limit. If you speak to some of our manufacturers, there's ways they have products that might extend Cat 6 and PoE over category cable beyond this distance. That's fine, but that's not what meets the standards. The standards is this is a hard number. Can't really go beyond that. So this guarantees the speed. So a category 6 cable, it may go faster, but this is the minimum speed that it guarantees. All right, and then so category 6A is 10 gigabits per second. There's an asterisk here on the gauge size of the 4-pair conductors inside a category cable. So the standard is generic, and it says it needs to be 22 to 24. So you pull down the spec sheets from a variety of manufacturers. Cat 5e, you're most likely going to see 24 gauge. Cat 6, likely going to see 23 gauge. I actually had, I don't know if it was my project or one I just heard about, but I guess this was probably about 10 years ago when Cat 6A just came out. Someone wrote a spec, it might have been for a government job or a city job, that said Cat 6A but 24 gauge. Well, nobody made a 24 gauge, so we were scrambling to find anybody that had that because that's what was in the spec, even though it didn't exist. So it just comes from, I think, lazy design, a consultant's perspective where, you just changed the Cat 5e to Cat 6 and didn't bother to know that you had to change the gauge size. Just so you know, there are other category types you might hear about. Cat 7a, that's a European standard. They use non-RJ45 connectors. If you deal with audio video at all, Crestron will be glad to sell you a very expensive Cat 7a cable to do their 4K distribution over. But that's not a ratified standard here in the US, so we don't deal with that. Category 8 was just ratified by that TIA standard, and that's specifically geared for data center applications, and the distance is 40 meters or 24 meters for speeds up to 40 gigabits per second. As we talk about making our initial selection, we have to talk about PoE, and so IEEE has defined the PoE requirements. So these have just been ratified, types 3 and 4, PoE++, and higher power, and so we're expecting that to be published here soon, whether this year or beginning of next year. So far we've been designing around 30 watts and 15 watts, right? And this is how many pairs that the power goes over. So your type 1, your 15 watt, just over half of the pairs. And this bottom line that's the delivered power. So if you have a 295-foot cable, there's going to be voltage drop in that, and so this is the max watts that we can guarantee at the end of that link, permanent link. Also, there's supposed to be a closed parentheses here, so pardon the typo. So when we look at which category cable is best for PoE applications, for cameras, or any other potential security device, if it's 60 watts or less, this is our dividing line. So if we have 60 watts or less, then category 6 cable is sufficient. And that's because it generally has this 23 gauge. So I talked with, was it Sony yesterday? Asked them, okay, your 4K camera, full resolution, full frame rate, how much speed are you delivering back through your switch to your NVR? And they said it was, I have to check my notes, it was 20 megabits per second. So not anywhere close to that 1 gigabit per second. So there's no need to spec out a Cat 6 cable. It's more expensive for your applications up to 60 watt PoE. Again, this Cat 6 is the sweet spot. I've had some clients where Cat 5e only, but again, that's a 24 gauge cable. Can't really recommend that to support, what we expect to see a PoE camera. There's a question in the back. Yes?
When I'm talking to customers and integrators and they're doing cameras and video and pulling Cat 6, my first question is this going indoors or outdoors?
Oh, well.
And where are you?
Oh, I'm going to get to that. That's in the code section.
One of the specs that you have on it, you have the 10 gig, 1 gig, the gauge of the cable and the distance, and obviously the cost, but my understanding is that the temperature ratings of the cable.
Oh, yep.
So the Cat 6A.
Yeah, you're jumping ahead. So
okay, sorry.
We'll get to those. Don't you worry. Hey, good question. We're forward thinking. We're engaging the audience and the speaker. So closing out this section, just so you know, there are shielded category cables. Generally, I don't like to specify them for security applications because I don't see a benefit to having that on the spec, but I wanted to just go through the different types because this was, I'll say, threw me for a loop, but it confused me a little bit. So if there's foil around each individual pair, right, it's unshielded foil twisted pair. And then if there's an outer foil and then it's unshielded around the individual pairs, it's foiled unshielded twisted pair, and these are called screen twisted pair. So obviously there's a metallic element to the cable, which then you have to bond properly, at least at the patch panel level and at the jack, at the camera level. There's additional time to do all of that. So generally I don't see a benefit to that, and I don't spec out a shielded cable. Yes, you in the front row from Portland.
Yes, we're going to keep it weird, okay? So where would you consider running a shielded cable for a camera application? My thinking is like maybe an industrial application where there's a lot of EMI, RFI type interference.
Yeah, that's a great question. So that's exactly the application where then you would want a shield, because it adds that extra level of EMI protection. which you probably should be in conduit as well.
Yeah.
So there's other ways to mitigate the potential EMI effect. So.
And along those lines, there's some applications where we float the shield at the end of the run. With cat cable, we're actually having to terminate in the RJ45, and there's a special RJ45, I believe, for shielded.
Oh yeah, absolutely. It requires a shielded jack, and it's a little more time consuming. So for most of your applications, it's not what I would envision as being a requirement. I didn't put it on the slide, but some manufacturers will make an almost shield, so it'll have an outer shield, but it'll be non-continuous, so there'll be a spiral in it. So you get the 99% of the effectiveness of having the shield, but you're not having to bond it at the end because it's not continuous. So I thought that was neat. Not every manufacturer has that.
Real quick question.
Yes,
or statement.
Yes, you in the middle row. We might allow statements, but you're wearing blue, so okay, I'll allow it. If you had a red badge.
Real, just quick statement.
Yeah.
There are manufacturers on the camera side, including Axis, who have in our warranty statement for cameras that are placed outside, it needs to be shielded, twisted pair for the warranty to be valid. So that is just something to keep in mind as specifiers when you're putting cameras outside. We're not the only ones who require that or for that warranty to be valid. So
Good
that's
to know.
another thing to just keep in mind.
Thank you. All right, next up is NEC Code Requirements. So this has been a sticking point that I sort of came around on the code. Normally, category cable, you think Chapter 8, right? That's where your requirements are, and Chapter 8 is disconnected from the rest of the NEC, except where it's specifically referenced back in. But what I learned is that if it's category cabling data only, Chapter 8 is probably what governs. But as soon as you put that PoE application on it and you're driving power down it, that's where it rises to the level of a Class 2 cable, which is governed by the NEC Chapter 725. As you alluded to earlier, it has to do with the heat, especially if you bundle cables together. So before the 2017 edition of the NEC, it gets updated every 3 years. So before 2017, the NEC anticipated some of these higher power PoE applications, specifically for lighting and camera applications. And they logically applied the thought process that when you're pumping 100 watts down a category cable that's just routed in your plenum space, not in conduit, there could potentially be issues, right? So they went out to UL and they did testing on a variety of cables that are 22, 23, 24 gauge. I think they did 25, 26 as well, some of the niche manufacturers. And those cables are tested to certain temperatures, just like the power conductors. So usually it's 60 degrees Celsius, 75, and 90 degrees Celsius. So they went through all of the testing, and they found that the middle cables, when you bundle them in certain numbers, the temperature rises above the threshold of what that cable was is rated to. So that is a problem, right? Because if the cable melts, right? NEC is a life safety code, so we're trying to prevent fires here, and melting cables is not something that we want in buildings when we can prevent it. So what the NEC 2017 allows is that if your manufacturer's cable is of sufficient quality and gauge size and can be used with PoE++, 100 watts, certain amperage, then the manufacturer can go ahead and list that cable with a special LP designation, so that when we're walking the site or the AHJ's walking the site, we see PoE lighting or cameras, cabling all bundled together, we can look and see LP. All right, we know that this cable is appropriate for this application. And again, so you'll see some of these on the market, they'll have a higher gauge, 22 gauge, to help with that power distribution. Some manufacturers aren't rebranding their cables. They say that their cables already meet that requirement. Don't want to spend the time to update their manufacturing or their marketing or their PDFs, cut sheets. Whatever reason, they're not doing that, adding the LP, special LP cables. And there's an exemption in the NEC. So at the end it says, okay, well, you don't need to run an LP cable, but then you need a professional engineer to sign off and do the design to say that what's being installed is appropriate and will work appropriately. So again, 60 watts and under, Cat 6 is fine. If you've got some forward-thinking clients, or you know you want to design around that 100 watt, then that's when that LP cable comes in. And again, we're not dealing with high bandwidth, so it only needs to be Cat 6, but here's an example of a manufacturer that has an LP cable, but they only brought it out for Cat 6. So there's definitely going to be a price premium. If you do some research, there might be, I know that there's at least one that has a Cat 5e or Cat 6 LP cable. Again, 1 gig speed's all you need. It's just making sure you have that higher gauge size. Yes, you without the microphone.
Are you familiar with CI cable for some life safety requirements?
I am not.
Okay.
As well versed as perhaps some in the audience.
No, I was going to ask, the question I have is, so you don't know if anybody's has a CAT cable that meets the CI cable requirements, which is 1900 degree.
Circuit integrity for survivability reasons?
Yeah, level 2, level 3.
Yeah, so survivability is governed by the NFPA 72, and the short answer is no, no one has it yet. A couple people have one that's rated for transportation purposes that meet the London Underground application, but as far as meeting a UL listed, testing to have a survivability rating, the answer is no. So the solution is still conduit with a fire wrap is what I'm designing around, but that's a good question.
I just want to add to it. So recently there has been, but none of the manufacturers that we typically use. It's overseas. You can type in a search engine, pop up something.
But it's not
overseas.
UL. It's not NRTL.
Correct.
Yeah.
Right. So it's not going to be your CommScopes, your bandwidths, or Siemens, or that type of thing, which is what normally you use in the category side. But it's out there. But like you said, it hasn't been vetted yet. And that's with anything else as well. Coax for DAS and things like that. If you guys are doing DAS, same things.
Great. So moving on to a separate topic, that is the NEC defines what wet and damp locations are. So your wet location will be, anything in slab on grade or below slab on grade, conduits out to your light poles where you have security cameras on. Definitely your wet location. The damp location is if it's under an awning. So if it's outdoors but it's under an awning. And the way that, again, I'm reading the code, there's some code hopping involved, but because we're in 725, that jumps down to, refers to section in 300 and then 310 that says, okay, well, if you're routing a cable in a wet location, then it needs to meet one of these 3 requirements. Moisture impervious metal shield, and then these are all electrical power conductor types, and then the bottom is it can be listed for use in wet locations. So that's where I'm at with it. It needs to be an what we call OSP or outside plant cable, And as we just heard from manufacturer, we now need to make sure that's a shielded cable out to the camera on your site. And no category cable manufacturer makes a damp rated cable. So it's one or the other. It's inside plant or outside plant. So my opinion is you've got a camera out on an awning, the conduit's in a damp location that still needs a OSP cable. I have a question here from somebody without a microphone. Hot topic.
What about the SuperCat 6 cable, which is water protected?
I'll get to that. There's a couple slides. The problem with OSP cables is that they're unlisted for routing inside a building. So you have a plenum space, that's your area above your drop ceiling, but below the structure, that is used for return air. Then any cabling in there needs to be plenum rated. So that's our main design parameter. So best practice, getting into some of the specification side of things. You've got a site camera, make sure it stubs up directly into your telecom room. If you've got an existing building where you can't do that for whatever reason, you come up conduit on the side of the building, and then you go into the ceiling space. Again, it can't, if it goes into a plenum space, the code says that you can extend that unlisted cable through RMC or IMC, rigid or intermediate metal conduit, to where you need to go. The code also says you can route it in a building 50 feet, but that's if it's in like a mechanical room where there's no ceiling space. So if you pierce through the side of your building with your camera conduit, again, if it's in the plenum space, extend it in IMC. If it's into a mechanical room and you're trying to you can get to your rack within 50 feet, you don't need to transition that cable. If it's convenient or able to, you can try to splice it from outside plant to an inside plant cable. Again, I try to avoid that. And then, as you mentioned a few minutes ago, the other option is to spec out a specialty cable that's both outside plant and indoor rated. So Hitachi just released Hitachi just released a dry bit cable that's outside plant and wet rated. I don't know if it has a shield on it. I can't remember, so I'll have to go back and check on that. Mohawk makes one that's just CM rated, maybe even riser rated. That's also outside plant. So those are the two that you can look to see what their outside plant, so you can avoid that transition point or extending expensive conduit through your building. And then the last major NEC requirement is lightning protection. So again, this is specifically what I was mentioning earlier. Don't take what I'm saying here as gospel. This is just giving you some high level, here's what the code says. Here's actually an image from Bixby showing a zone of protection. What's inside this cone generally isn't susceptible to lightning strike. So if you've got a corner mount camera, then better be safe than sorry. I'd probably would protect that. But if you've got a camera on the ground here, or ground level attached to the building, wouldn't need to protect that. If you've got a light pole here that comes up and you've got your camera attached to the top, just sort of draw a 45-degree angle from the top of your building, and that's a general rule of thumb of when you need lightning protection. The NEC says there's two main exceptions to when you need, where you don't need to provide lightning protection on our low voltage cable. The first is if you're downtown in a large metro area, like we're here in Nashville. You've got very tall skyscrapers, which should have a lightning protection system, or lightning will strike the higher building. You don't necessarily have to worry about it on your project if you're downtown. The other caveat is if you're an area of the country that has 5 thunderstorm days per year or less, then you don't need that. So I was new to the West Coast. Apparently, if you're within 100 miles of the Pacific Ocean, your threat of thunderstorms is really low, so you don't have to provide protection. I learned that by calling someone at the college to ask, because we did a tour of all of their 2,400 pair copper. There was no entrance protection, and I was trying to call up their IT department to say, you want to do anything about this? And the guy looked at me like I was crazy. So it's definitely a new learning curve moving to Portland from the Midwest, where we don't have to worry about
I will tell
lightning.
you that's changing there. We're seeing more thunderstorms.
Okay.
Yeah, so I would definitely, I always protect anything between buildings, please.
Yep. Yeah, as you said, best practice. Dave here is also in Portland. He's still specking out lightning protection. That's a good best practice to have. I'm not saying you don't do that. I'm just saying that this is where the code says you have to have it, and here's the exception. Jumping into specification best practices, and feel free to chime in here. A lot of these are Matthew Peterworth best practices, including this first slide. So if you happen to have a project where you're also the telecom designer, right, it makes sense that the cabling spec live in 27 or be governed by that telecom cabling spec. That's great. And if you have another consultant on the project that's designing Division 27, it should be a simple phone call to them to say, hey, can you provide the cabling for the cameras? And you can coordinate that. Now, what you don't want to happen, which is what happened on one of my projects recently, is I had the security design scope and they had the cabling design scope, and they put a general note on their drawing on their title page that said, provide the category 6 cable to cameras, see the TY drawings. And guess what? We're a week before substantial completion, 2 weeks before the owner moves in, and none of the 50 cameras have cables. So if I have a project where there's scope that needs to be coordinated between consultants or whoever, I don't like, if it's over like $10,000 worth of scope, I don't want a general note covering that. It needs to be either a symbol on their drawings that matches the camera locations, or it needs to be a detail or something that draws their attention, because I don't like to live by general notes or a line in the spec that says, that defines over $1,000 worth of scope. So just keep that in mind. At the end of the day, though, on some projects, especially if they're security only, or if we want to keep the cabling scope under our security integrator for a variety of reasons, I'm of the opinion that it will increase the chance of a successful project if the security integrator owns the cabling scope. So some projects, again, 27 data application, telecom contractor installs that system, and then the security integrator may want to sub out their cabling to a different contractor or do it themselves. And we'll get to that here in a little bit. So that's sort of why I'm of the opinion I make a standalone telecom for security spec. I drop it in 28 right underneath my 2810.00 electronic security systems. So that's all governed by, if I want it to, it's all governed by or owned by the security integrator. So this is not in CSI's index. This is just something that I've been advocating internally at PAE, and was something that I had developed at my last firm. Next thing I like to specify is modular patch panels. So you go to a random manufacturer, or if you don't bother to specify, you don't know what kind of patch panels you'll get, or if you'll get patch panels. I guess a lot of integrators like to do direct attach right into the network switch. So we need to make sure we spec out A, patch panels, and B, I like to do modular because it has individual jacks. Working at the University of Texas, I did I'll say a field visit to a IT closet in one of the schools. One of the cables stopped working, and we were sort of adding to that telecom room. And so it was an adapter. So there was 6 cables terminated onto an adapter that sort of snapped in. Well, one of them was bad or broken, right? And so now you have to worry about downtime for the other 5 cables on that adapter if you have to fix it, right? So again, advocating for individual jacks that snap into this, so it helps with moves, adds, and changes moving forward. For whatever.
Seen on a cost difference for labor for them to wire that up versus a possibly batch?
Well, the frame is empty, right? So this cost is down. As far as labor, I'm not a contractor. I couldn't tell you if it costs more. My hunch would be that it wouldn't cost more. It would probably be quicker to terminate it on a jack and then snap it in rather than trying to work behind a single patch panel with a 110 strip on the back.
It is a little bit more. From what I've seen, it's just because of the individual package.
Okay,
jack.
yeah.
It's more because of that
Yep.
reason. Labor-wise, it's going to be the same.
So labor-wise is the same, gentleman in the front row says, and then, but the cost of the individual jacks raises the cost up a little bit. Another advantage of doing this is you can color code the jacks, so data can be white or blue. You can do purple for security, so you have that color coding possibility. When we talk about jacks, so RJ45 is a term thrown out there. I was politely corrected by a coworker once that that's sort of a slang term. The technical term on the industry side is 8-pin, 8-conductor modules. So if you see a project from me with details, you'll see this a lot, 8P, 8C. So here's an example of your female jack. Ron was talking to me a couple days ago when we arrived about are we doing male jacks in the field at the camera. So Bixby had a security installation standard from a couple years ago that allowed what we call this direct attach method at the camera. And of course the integrators have been doing it for years anyway, right? So finally the TIA standard was just ratified last month that actually finally allowed it for data applications across the board. So before we were doing direct attach, okay, we can kind of do that appropriately under the Bixby standard, but now the bigger TIA standard allows it. And so what you're seeing here is a special field terminated male jack from a manufacturer, and notice that it's a lot larger than what you see at the end of a patch cable, right? So this is there for a reason. So when we get to a couple more slides and I list the list of manufacturers that I would specify for structured cabling, you know, I haven't gone through every single one of them, but I would guess that they have a product similar in size and shape for this particular application. And just, still doing some research onto why we need this, but the logic that I'm applying to it is you can't just use what you do at the end of a patch cable, because that's made in the factory, terminated in the factory, pre-tested, and they might be smaller gauge size. They're just not built for field termination. So this is designed and built to allow what we're trying to do, which is 60 watts or maybe even 100 watt PoE connections. So you can talk to Access to. Do you have anything to add about this?
I was just going to say that the size of that sometimes might not fit into a enclosure in certain camera housings, right? So you might want to take that into account. It's great to go into the switch on the switch side, but if you're doing direct attach to an endpoint, understanding how much room is in that endpoint is important.
Yeah, good. That was a talking point I forgot. Thank you for adding that. So again, lots of exciting stuff here. Copper cable testing. You can actually go to Fluke's website, or I don't know if it's locked down or not. You might have to find your local Fluke rep, but you can pull down Division 27 testing specifications that you can reference or even copy and paste into your own specs. But all of these parameters are defined by that TIA standard. So Category 6 cable has to meet, X, Y, Z. And I'm not going to go through all of these, but I've spelled them all out for you, except for this last one. I'm going to bring attention to that. So if you've got a Category 6A cable, if you got a client that's just Cat 6A everywhere, we don't need the 10 gig speed, but we have to meet their cabling, an owner's cabling standard. So alien crosstalk is costly and time consuming to test, and it's per manufacturer's instructions is what I write in there, because it varies from manufacturer to manufacturer, and not every cable is tested just because it's so costly and time consuming to do. So there may be a 10% sampling for that. Yes?
I have a question for you and maybe for some of the other consultants in the room. Altronics has a product that we use for long-range Ethernet, or extending that Ethernet beyond that 100 meters. Mm-hmm. And the biggest question that comes up to us is, how do we certify that cable? In some specifications that are written, the cables have to be tested and certified. When they have to run cables that are beyond 100 meters, where they're doing extenders, or in our case, a point-to-point up to 500 meters, let's say, how do integrators go about certifying that cable for networks when there's not a device out there that'll certify it?
It's a good question. Let me get to that when I talk about
Yeah, and I guess another part of that question is, how do you get around that if it's written into a specification?
Yeah, so one way is to not do category cable to go over distance. I talk about fiber, PoE over fiber in a few slides. Another option is to do PoE over coax, so you're not limiting yourself to the Ethernet standard where the cable needs to pass the test results in the spec, right? So that's one way to do it, but when you get into the PoE over coax, there are good manufacturers and then there are not good manufacturers, right? So as consultants, I'm sure you've had mixed experience with that. So moving into the fiber, which we'll get to our PoE over fiber here in a couple slides. Just a brief overview, right? So there's 4 types of multi-mode fiber. The most common are your OM3 and OM4. Those are your currently what you want to design around. You'll see, especially if you have backbone fiber you need to include in your project. You either do OM3, OM4 multi-mode, or you do single mode, and we'll see the throughput on that. OM1 and OM2 are your legacy fibers that you would only match an existing owner. If an owner has OM1 for whatever reason, because it's a 20-year-old cable, and you need to relocate that. That's the only, that's the only reason I would ever spec OM1, is to match an owner existing. And then here are a couple common connector types. LC is going to be your most common in that duplex format. There are half a dozen others connection types, but again, not, we're just trying to use fiber to get what we need, and if the client that has an IT standard that will specify what connector type, great, follow that, and you can just write that into your spec. But if not, LC is fine. So if you're doing fiber backbone for your security applications, this is just a chart I pulled from Bixby, right? So if OM1, OM2 are good for up to 1 gig, up to certain speeds. So you're looking at OM3, OM4, good up to 10 or 100 gigs at varying distance. And then of course, single mode is the best. It has the highest bandwidth potential and the highest distance. Historically, though, the single mode electronics at the end have been more expensive. That's why we've been, designing around multi-mode when we need to, because those electronics have been more cost effective, but we're seeing a trend down that single mode is the cost of the electronics is, you'd almost be a fool not to do single mode in certain applications at this point. Even if owner is OM4 today, I'm still putting in single mode backbone until they specifically tell me they don't want it and we don't want to pay for it day one. So next up is PoE over fiber. So this answers your question. I would not do a PoE extender using category cable to go beyond that 300-foot distance. Just the best practice, because as you said, if the cabling spec says you need to pass the test results per the TIA standard, then yeah, you're going to come into a complication. So the solution to that is to identify your camera locations ahead of time that are beyond your distance. And I've been again advocating for PoE over fiber. So this is a composite. Generally, it uses a composite cable that'll have a low power, a couple conductors for power, copper conductors for power, and then two pair OM3 or OM4 multi-mode. And these, so CommScope, Berktech, Altronics, these are who I would write into my specs. There are others out there that you need to vet to see what they're.
So going back to your discussion about surge protection, lightning protection.
Yep.
So even this composite cables, that's a consideration we have to build into this. We have to split this cable apart, take the copper section through surge protection if we're going out to a light pole, out in the middle of the parking lot or something. So that's another complicating factor to this.
It is. I've had an RFI about that issue, and I think the solution was a substitution request away from this product down to a PoE over coax. Didn't necessarily like it, but that was one of the deciding factors was then looking into the bonding requirement. So this product in particular, the Berktech one, it's trying to pull teeth to get that kind of information out of the manufacturer. So yeah, you're not wrong. It's a difficult thing to consider. I'll probably have the same conversation with Altronics after the presentation to see how they're dealing with that particular issue. Maybe they don't. I think they do. So another thing to consider is a couple of these need to be in a NEMA 4 enclosure out on your light pole, so that, or in your parking garage. CommScope's already comes in a NEMA 4 enclosure, and it's a wet rated patch cable out to the camera. Yes.
Matt, in the Berktech application, we typically put a PoE surge suppressor between the remote port and the camera.
Yeah, that's a good, also a good best practice. Thanks for bringing that up. So there's some smaller inline RJ45 in and RJ40 out inline surge suppressors that go at the camera location, and then at the telecom room you can come in. There's a couple good products. Some of them are built into the PoE, potentially built into the PoE extender. Some of them are wall mounted. There's some rack mounted options in there. So it's a fun, challenging thing to get into and design appropriately. Usually if I have more than 6 cameras coming in that I know will be needing some surge protection, I'll do a rack mounted solution. So my specs sort of, 4 or less, you can do the wall mounted ones from Surgex or whatever, and then 5 or more, do a rack mount surge suppressor on these. Ooh, fiber testing. So again, I encourage you to go to Fluke, download their testing spec. I think it's written this way, but this is how I've been designing, is to do a phased testing. So the first part is an attenuation test with this tester, optical loss test set. This is a lower cost tester. It's a quicker test. And if it passes, then you know, okay, this fiber link is fine, right? And then if it fails or is marginal for whatever reason, that's when part 2 kicks in, and then we ask that the contractor do the full fiber testing with this OTDR, which is the optical time domain reflector, right? So some clients will require OTDR test on all strands, right? But that's more time and more cost. So if you have a client that doesn't care, this can save some testing time. Another thing that didn't make it onto the slide is for fiber testing. If you've got fiber on your project, I write in contractor qualifications, Big C level 2 fiber certification or equivalent. And we'll get into what that equivalent means in a couple slides. But Big C level 2 fiber, because they've got copper, level 2 copper, but listen, you know, I trust the security integrator to install and test a copper cable. When we get into fiber and we're relying on it, especially on a backbone application, make sure we test all the strands, and adding that level 2 certification from Big C for fiber is something I write in there. So again, here's what a test result would look like from a OTDR, and it is able to measure the distance and the loss through that connector. So all of the overall loss has to add up, and it has to be below a certain threshold. Part of the phased approach is if there's an issue, right, it'll tell you where in this circuit that there's an issue, right? So if it's obviously been installed, if you're testing it, you can sort of almost pinpoint where that failure occurred. So you can, when you pull another fiber cable through, you're not going to replicate that damage, hopefully. Another thing I write into my cable testing specs is to reserve the right to ask for retesting. Another way around that is to say, invite me as the design consultant, me or the owner, to view your testing. Tell me when you've got that scheduled, give me a week in advance. Maybe I'll present myself to observe you doing the testing. Another way to do it is if you have a final punch walk, you can stipulate, okay, you need to provide 2 technicians with the testers to be available for 2 hours on your final walk, and then you can have them spot test up to a certain percentage of cables. You know, I would only do this if I'm looking through the test results and I see the time is the exact same down to the minute, right? So this has a second time frame. So I might be, there's been a couple projects where I've seen the test results, and there's been a couple circuits that have the exact same time in the minute hand. I'm like, I don't know how fast you can test cables, but I'm thinking that you just copied this and just changed the circuit number on the top. So that's when I want to have something in my specs that say, okay, when I go do my final punch, hey, now there's something that says, okay, contractor, be on site with your cable tester and prove to me that this circuit passes. And if there's a certain percentage that fail, then the contractors are responsible for retesting. But then again, I say I've got that highlighted, contractor or third party. If I don't trust the contractor to test the cable properly, why am I going to trust them to retest the cable properly? Right? So if you write in a third party retesting, you need to make sure that it's stated that the contractor's paying for that. You see third party, implication is, oh, third party's going to retest it. Third party's going to pay for that third party retesting. But no, you need to make sure that it's going to be paid for by that contractor. Fortunately, I haven't had to deal with this for the last 10 years of my career. But I did have a fun project that went into litigation a while ago on the AV side of things, at least. Next slide, there's a lot here on advanced system warranties for structured cabling systems. So I've given a whole presentation to Big C on this. So you type in Peterworth, Big C, warranty. The slides for that whole presentation you should be able to download So I had a 50-minute presentation just on this slide alone, but I had to be vendor neutral or agnostic because I was at a Bixie conference. The joy here is I can tell you some of the manufacturers so you can benefit from that. So for whatever reason, structured cabling manufacturers, I think to meet customer demand or to distinguish their products to customers, to building owners, started offering 20-year warranties on their category and cable and fiber installations. And it covers all passive components, including down to the patch cables if you spec out the patch cables. So it's the patch cables, patch panels, the cabling, the fiber enclosures, the terminations, all of that is covered by the manufacturer. And it guarantees the performance of the cable. So that TIA standard says Cat 6A, good up to 10 gigabits per second speed-wise. That's what this warranty will guarantee. If TIA later adopts 568.D.7 and says that category 6A cable should now meet 11 gigabits per second, even though that's a future change, the way that most of these warranties are worded is that it still will guarantee the performance because it's built to that standard. Repair and replacement is covered by the manufacturer. You get into the weeds a little bit. Some manufacturers will tell you that maybe the product's covered but not the labor. So you can get into that in a little in your own research because I haven't done that on a micro level. The other thing attached to this is the warranty is only offered through certified contractors. And I've got my next slide is on this topic, so I'll touch on that in a little bit more in about 30 seconds. The other thing to know is that some manufacturers will only offer a warranty if you use their cable. So the way we divide up structured cabling, you've got connectivity, which is the jacks and the patch panels, and then you've got the cabling side. So some will only offer the warranty if you use their cabling with their jacks. Other manufacturers have cable partners that they partner with and will extend that warranty to cover the system with someone else's cabling. And there are some of them have different tiers, so they may have a preferred cable partner. So Panduit General would be a good example. Pan-Gen warranty, 25 years. But if you come back and do Panduit with another manufacturer on their list, it may only be a 15-year warranty. It's good, bad, or indifferent. I write in 20 years because it elevates it beyond that 15-year warranty where, yeah, you're an okay cable company, but we're not doing our due diligence. So 20 years is where I write into my spec. Some of them will be 20, 25, lifetime warranty. Thinking of value add to the owner, how great would it be if the cabling for the cameras is guaranteed to work for the lifetime of the building. So that's something that I'm trying to write into my specs. It's just an example from Belden of their warranty and what they say they will cover. The benefit of specifying the advanced system warranty is because these manufacturers have a certified contractor program. So I have projects all over the country. I don't have time in my fee to go out and research who the good structured cabling installers are, to pre-qualify them, write them into my spec. But I can list certain manufacturers, and then they have done the due diligence in each city, in each market, to say, okay, we trust these contractors to install our cables in our systems well enough to offer a warranty, this 20-year warranty. They also make those contractors go through training, both on the installer level and on the project manager level. So that's where I say Bixie level 2 fiber installer or equivalent. The equivalent would be the manufacturer equivalent fiber testing training. Another potential requirement, the manufacturer may require that the contractor have a VIXI RCDD on staff. This is listed in my Division 27 requirement. If I've got remember I got that Division 28 specialty telecom for electronic security section, and I just have copper, then I'm going to delete that requirement from my spec. But if I have fiber, I want to do a little more due diligence and expect a higher level contractor, then I'll make sure that I have that in there as a contractor requirement. In addition to because not all manufacturers have that as a requirement. Some manufacturers will also limit the number of certified contractors they have in a city. And they do that probably for sales goals. So, companies A, B, and C are certified with this company. And just as a motivation to when a project comes out with a spec with cable A, manufacturer A, they go to guarantee a certain number of sales. So just be cognizant of that. That will come into play if you've got a client that has a hard spec on one manufacturer and there's only 4 in the area and they're all too busy to be on your project. That could be a problem, because when you try to bid or add a contractor that's certified with them, the answer will be no. We have to wait for one of the other 3 to drop out. So they're generally recertified every year, re-upped, and then if there's a difference, then you can go in and try to get added to the contractor can try to get certified with who they want to be. Another thing to note, the testing requirements will vary between manufacturers. So like Systemax, and we'll get into the next slide, all they care about is wire map and length, and they trust that the installer has done a good enough job and that their cable will pass the rest of the tests, right? But that's why in my test section I still list all of the testing requirements, all those PNECs, all those category requirements. So here's the money slide, right? This is the list of the what I call top tier manufacturers. So I apologize to those that in the room that are manufacturers and aren't on this list, but this is who I start with, right? And sometimes I'll deviate from this if there's some sort of supply issue. I hard spec'd Corning once for fiber, and they happened to be redoing their plant that week and they couldn't bring it back online, so there was a huge delay on Corning. I had to rebid that entire project because the client wouldn't let me allow a substitution request. So that's the level of I'll say down to the level of design. As consultants, we need to worry about supply sometimes, but generally client their IT standard might list Ortronics only, right? Then you have to follow their requirements for cabling on the cabling side. One thing to note, I've highlighted these manufacturers on the cabling side of things: Hitachi, Mohawk, Superior, Essex. They are willing to offer a warranty. They don't care whose connectivity is on the end. I found this beneficial because if you've got a client that says, I need Panduit jacks, that makes sense, right? Because if they're doing their own moves, adds, and changes, they don't want Panduit in one building and then Belden in another, and so on and so forth. They want to have consistency from building to building, especially on a campus environment. Hitachi, Mohawk, Superior, Essex, if you're doing their cable, they will offer that warranty for anybody's jacks that's on this side on the left. They also don't have restrictions for the quantity of certified contractors in the market. So you've got an security integrator that you want to get certified so that they can install a project with a 20-year warranty. I'd start by reaching out to these manufacturers and get them certified. So then the last bit that I care about is the project closeout submittals. These are things that sort of slip through the cracks. So when I try to do my final punch, and I haven't seen these yet, and then I will add in there as a line item in my punch. You need to provide as-built drawings, test results, your advanced system warranty certificate, and then again, one of my pet peeves, the cable IDs on the plans need to match the cable ID on the test results. Otherwise, how do I know that this is truly for my project? So you notice here, those are different. You know, whatever, you know, not that I don't trust contractors or integrators, but, you know.
But you just don't. You just don't.
I just don't.
Admit it.
Yep. So I definitely write that in, and that's it. This is me, whatever, 20 pounds lighter, a few years younger, and not installing cable. That was the photo op.
I just wanted to talk about the cable extender issue that you brought up earlier. I agree with you that it is not best practice to add a Cat6 or like a Cat6 extender onto a line.
Mm-hmm.
But sometimes it's inevitable. It has to happen. From a testing perspective, what I would suggest is you test both sections of the cable, because that media converter to some extent is kind of acting like a switch. It's taking the information in, repeating it, and sending it back out. So to me, it's the equivalent of adding a network switch somewhere, and you're simply testing one link up to that media converter, and then you test the other link. As long as both links are within 90 meters and they pass the test, there shouldn't be a reason why it shouldn't work.
You're right, that extender is it's a one-port switch, right? But the product I'm talking about is you have a receiver at the head end, and 500 meters later you have an adapter that's going to get back over. That's what I'm talking about.
That's well, I mean, from a networking perspective, I'm not sure that would work anyway. I mean, that would be pretty difficult, especially if you want to actually keep to the speed that you're trying to achieve. You know, if the cable is a 1 gig cable, I don't think it's going to happen. I have done significantly long cables, but not for Ethernet purposes. I've done that for broadcasting purposes, where a national broadcaster at a sports venue needed a 4-pair cable, but for a non-Ethernet application, and they told me straight out, it can go 1,000 feet. What we're going to throw on it will work perfectly fine. That's the only exception I've ever done.
But we do have a lot of projects where we use our product's called PACE. So, you know, the runs are 2, 3, 4, 500 meters. And the distance limitation there is actually the data is 500 meters. It's not even the POE. So we do have this in a lot of applications, small apartment garages, those types of things. The problem is that when they, from end to end, there's no solution for testing that for Ethernet at 400 meters out.
Yeah.
It's almost like a crapshoot.
It will work. So what I would suggest is it won't get the 20-year warranty on that cable that's that distance, because it doesn't pass the test result. If you need to get in writing from the owner that that's okay. I seldom have owners that engaged that would object to it. They understand that there's a hard limit on 295 feet to get out to a camera or a data application, right? So they're willing to allow us to, whatever we need to do to extend out for that one jack. I haven't seen any resistance, and as I said, you know, had an RFI on a project once. We've actually bounced it back to coax to avoid that issue. Lead with fiber, come back to coax is generally where I'm at. So, yep. Yes, Ron in the front row. You've got a negative 2 minutes.
All right, sorry. Excuse me. It can be done. And I think what Matt was getting to is the standards don't necessarily approve it or recommend it. I've seen several applications that's gone that direction. It's a matter of getting with the manufacturers. As Matt said, it's typically not your 20 or 25-year warranty. You'll get a cable warranty is typically what they call, instead of a solution warranty where it's end-to-end, it's a cable warranty only. It's not your 20-year or 25-year. You're going to probably get a 10-year, right? But not all manufacturers do it. So you can do it. It's not something in the standard. It's not something we try to promote. It's not ideal, but we all agree there's solutions like that that's taking place either from parking garages. And I mean, ideally, it can come down to budget, right? Ideally, we would want to put fiber everywhere and do this, and that's the whole direction. But I think we've all seen that where it doesn't go that direction. And the second thing I wanted to talk about, not necessarily trusting integrators in regards to testing, but there's a lot of things that are being taught that are not done properly in the testing process that what Matt mentioned that you want to bring up. The biggest thing that we're seeing right now is like zeroing or referencing cable in regards to fiber optics. So typically what happens, you should never see a negative result. People are going to, talk about that from the OTR standpoint, but from a power meter standpoint, you shouldn't see a negative. It should, there should be some type of loss that's created in the fiber. And typically what happens, Fluke's meters will still pass that test result or that fiber with a negative reading. So if you're looking at a summary, you're going to see that it passes. And so what happens is these contractors, when they go to reference, and I don't know if you're familiar with testing parameters for fiber, but typically when you go to plug into a fiber optic cable to test it, you've got kind of like a transmitter receiver on each end, and you're plugging into it. So what happens is the patch cord that's used to tie that device on each end has to be referenced and zeroed out, so it's not included within the loss of the test that you're doing. So what happens is we take it straight out of the case, right? You plug it in, you reference it, and then the contractor basically is taught to basically wipe the end of it with alcohol and stick it in. So basically he's made that connector better than what it was before we did his reference. And so what happens is the test result comes out negative, all right? And actually I've seen connectors that have been bad that have passed because of that negative and the way they've done the alcohol. So sometimes it's the way they're taught. They don't do it purposely. But I think what Matt was getting at, it's for both, right? There's some that just maybe not have best practices, but there's some industry issues, even with training, that these guys are just, not cleaning properly or doing that, and they can prevent that test result issue. And, you're not finding out about this until that client decides to go to that next pair to transmit and receive on something else, right? So I wanted to add that because we've seen that, and that's been something big that we've found that trend with contractors not doing. So.
Great. Thank you.
Thank you.
Oh, thanks, guys.